Hey there. Alright, so in this video we're going to be walking through cluster analysis. Now cluster analysis is a family of methods that is typically used to identify meaningful patterns in a data set. So for example, the cluster analysis can help us identify how responses group together based upon some set of metrics or a metric that we have of interest, or uh, cluster analysis can be used to develop a classification or a taxonomy based upon a given set of observations. In here, with this example, we have a data set that involves vocational interest. And so we have a set of, we have demographic information. We have so like gender, education, and age. And let's just say this is a data set of students, I believe. And then we also have some information about their cognitive abilities, so their vocab comprehension, their reading comprehension, sentence construction, mathematics, and so on. But we also have some personality measures. We're looking at like stress, worry, impulse, thrill-seeking, etc. And we're looking at how some of these scores relate to vocational interest on a set of vocations that we have. So for example, we've got policeman, fireman, sales rep, teacher, etc. And with this data set, I'm interested in firefighting as my outcome variable, as my vocational interest variable. Specifically, I want to use cluster analysis to determine whether students prepping for a fire academy could be grouped together based upon their pattern of responses. And specifically, I'm looking at their math scores, their reading scores, and their stress score, because ideally, you want to be pretty smart in order to fill a job like a police officer, or a fireman. You want to have a good head on your shoulders, and you also want to be able to deal with stress fairly well. So we want to see, based on the data we have, we want to see how these participants, these cases, vary and or pattern based upon the responses. Alright, so we're going to go ahead and load this data set, and to do that, I went to import data set. I clicked from Excel and I browsed and found my data. Once I found my data, I clicked open, and then once I did that, it brought up a file path, and I just highlighted that, copied and pasted, and put that information here in my read Excel command here, where it's identifying the path of my file, and then I push that information into the variable excel.data. And then because I have so many different variables to choose from here, I just wanted to select a couple, and to do that I set up a data frame where using data.frame, and then I specified that I wanted to look at their math score and their reading score and their stress score with respect to their affinity for firefighting. And in doing so, I also scaled each of these variables, because when you're running a cluster analysis and you're using different scales might have different values, in the sense that larger values vary compared to smaller values with respect to distance. And when you're clustering and you're doing a cluster analysis and looking at how the responses are patterned together, one of the metrics you're using is distance, or Euclidean distance, which is the straight line between 2 points. The straight line between 2 points, in which case you're actually looking at the shortest Euclidean distance between 2 points to see how closely these cases pattern together. And so you don't want to have skewed data in a sense that a set pattern together because they're on different scales, as opposed to pattern together based on the responses. All right, so we're going to go ahead and run that. Actually, I'm going to go ahead and run this whole thing, and we're going to talk through it. All right, and run. And give it a few minutes here. And that's while it's doing that, we'll go ahead and move to our first bit of code here with respect to our cluster analysis. So first, we want to see, again, we're looking at how the data is patterning together. So first what we want to do is determine the number of clusters in our data set. So do we have a data set that actually is made up of several different clusters? One of the first methods we have for determining that is a gap statistic. And a gap statistic essentially is a goodness of clustering measure. Then we have our scree or elbow method. Then we have nuclear method, which basically looks through all different methods of clustering and selects the best one, essentially. But all right, so first let's look at our gap statistic. Again, these are the methods that we're using to determine the number of clusters that we have in this particular data set. So with the gap statistic, we're really only interested in this bit of code here, where it says it identifies the number of clusters as being 1. And cluster analysis, the thing about cluster analysis is because there's so many different methods and so many different ways of clustering, there's a bit of contention in the literature about, and among researchers about which way is the best way, because typically, depending on the method you use, you could determine that there's more than one or multiple clusters. So it could be 2, it could be 3, it could be 4, it could be 10, but it depends on how you determine that and which method you use. So I could have stopped here and just said, well, there's only one cluster in the data. But we're going to use some of our other methods, for example, our scree plot, where we're going to go back here. Where's my scree plot? Boop, boop, boop. There we go. Now the scree plot is essentially kind of like a factor analysis with the scree plot, or elbow plot here. We're looking at where the data points kind of start to slope off and decrease and level off, such that you get pretty plateau effect here. So we're interested in where this data starts to level off, and we see in this example that we pretty much only have 2 clusters, because as we move along here, the line pretty much stays pretty much the same across 4, 6, 8, and 10 clusters. So kind of our elbow joint, it's very shallow elbow joint, but I would argue that our cluster for this example would stop at 2. But let's go ahead and see what else. So we have our gap statistic that says there's only 1 cluster. Then we have our scree or elbow method that says there are 2. Let's go ahead and run or look at our nuclear method. And now again, as I said, the nuclear method runs all of these indices, runs a whole set of indices, and or looks at the which approach is offers the best number of clusters. So, for example, or how many offered that approach, or excuse me, the number of clusters. So, for example, 8 proposed 2, 2 proposed 3. So, for example, one of these methods, one of the prior methods here, could be one of the methods used to as one of these indices here. We're going to see overall over all of these indices, what is the best approach? And it's using a majority rule to figure out the number of clusters. And it arrived using this approach at 2 clusters. All right, so I think given the fact that we use 2 out of the 3 recommended 2 clusters, that is the number that we're going to go with. That is our k value. K means cluster. So now we've determined the number of clusters. Now we're going in, now I'm specifying how many clusters are there, or so I think. Well, my best recommendation from our the methods that we've run here is 2. So I'm going to go ahead and push that 2 into the numclust, and then we're going to use that in our hierarchical clustering approach. And essentially, this hierarchical clustering approach creates a dendrogram, and a dendrogram is essentially a visual representation of our cluster. So if I go ahead and go, should have already run it, boop, boop, boop. These are just some indices that were created when we used our nuclear method. So you see, for example, that out of all the ones that were recommended, 2 is the highest, and that's the one that we went with. But all right, so here is, if I can bring this up here, here is our dendrogram. And a dendrogram, basically, it's marking off how these clusters, or how these cases group together. So you could actually start from the top, or you could start from the bottom. Starting from the bottom is an agglomerative method, and that's typically, I think that's what we're using here, because we're using Euclidean distance. So you're looking at and treating each set of observations as its own cluster, and then you start pairing the observations to each other, see how they pair up on it. So you see a couple of pairs here, see how they start to group together on up until you get to the specified number of clusters that we identified in this bit here. And I identified 2 clusters, and so we see we have a border around the 2 clusters that I identified. This would be group 1, and this would be group 2, or cluster 1, cluster 2. All right, let me try to control my frame here, and we're going to go back down, probably right there. All right, so again, we're looking at using the hierarchical clustering there. We're using a dis command, which is basically talking about you're looking at distance between the observations, and we're using Euclidean, so it's a straight line distance between 2 points, and this and you're pushing this information into the value d, and then you have the hclust command, which is our hierarchical clustering, and you're specifying the type of hierarchical clustering using method equals, which is our Ward, the Ward method, which is a minimum variance method. And then you're saying, okay, based upon this information, I want to plot it. And again, you're plotting this dendrogram, right? So you're plotting these fit indices, all of this information here. You're plotting it into the creation of this dendrogram. And you're specifying the number of groups that you want to have the dendrogram cut up into, or number of clusters. Groups and clusters in this example are synonymous. Yep. And then, okay, so now we've essentially we've done the cluster analysis. We know that we have 2 clusters, and that the data that we have patterns together such that there's 2 distinct clusters. Now we want to start answering some of our research questions with respect to whether or not students prepping for this fire academy are patterned together with respect to our predictors, whether or not their response is patterned together in a meaningful way. And Now what we want to do as part of this validation is to use the traditional metric. Instead of standardizing these variables, we want to use the original metric. And to do that, again, I used a validation frame and push this information into the validation, the value validation. And we have we have groups, which is equal to group. And this is, again, referring to our cluster. And then we have the variable gender, which I referred to or had coded as sex. And then reading, which I coded as reading. Math is math, or mathematics is math. Stress is stress, and fireman as fireman. All right, so now, once we've done that, now we get into our research questions. So, for example, I have a set of participants, a set of students with a set of scores, and we want to know, because we're looking at selection, we're interested in whether or not they can, or they should be granted entrance into this fire academy. And one of the things we know about selection is that we don't want to create adverse impact across gender. So we want to go ahead and look at, do these clusters differ with respect to gender? So we're going to look here, and we see that we did a chi-square test, and we see that no, because our p-value is not significant, so no, these clusters do not, in fact, differ based on gender or sex. Good, that's great, that's what we want. Now we want to see, okay, do the clusters vary with respect to the outcome variable, affinity for firefighting? And we see we have firemen by cluster, and we do see, moving down here, we do see that there is a significant difference. We have 2.2 to the negative 16 there, so that's pretty significant, pretty strong significance there. So what we're saying is group 1 or cluster 1 significantly different, this mean score significantly different from this mean score, so 1 or 2. And we see that our cluster 2 significantly differently from cluster 1. So it could be that we have a set of more experienced trainees or more experienced students. These trainees for this fire academy, in the sense that they came in with some of their background might be in the military, or they might have worked for another fire department, what have you. That could be a reason that we're seeing differences with respect to our affinity for firefighting. So they really have an interest in it. They've done it before. They have that kind of experience, so they're rating it highly. Versus some of our new recruits that aren't really sure do I really want to firefight or what have you. So now we're going to look at start describing the clusters with respect to each predictor. So, for example, we have our math score here, and we see that. So again, this could be that we have some more experienced participants, more experienced students in our training program. But now we're seeing that the clusters, in fact, checking our significance again. That yes, again, significant, yeah, significant, significant, and significant. So all three predictors are in fact significant. So if I were to click over again here, we'd see that yes, they do. The clusters are significantly different with respect to stress, reading score, and math score. Now this could be, for example, we said we had students with previous experience. So this, but it could be that we have, this could not necessarily be a problem. It could be that we just have a really great set of new recruits this time around. And so this is where the recruits from last year performed on each of these with our cluster 2 here. But now these new recruits in cluster 1 are excelling with respect to their math score, their reading score, and how well they deal. Well, no, okay, no. I was going to say how well they deal with stress, but that is actually the opposite case here. They have more stress. So it might be that they have more stress as a new recruit as opposed to some of the more experienced members. And that is our validation of our cluster analysis. So because again, we're looking at how these clusters differ with respect to each other in terms of the pattern of the responses that we're seeing in the data. And that is how we run through a cluster analysis or conduct a cluster analysis. Cheers.